Hello everyone. Today we are going to discuss the topic about resultant forces in equilibrium of particles in engineering mechanics. First of all, we will discuss the problem. The four coplanar forces are acting at a point as shown in figure. Determine the resultant in magnitude and the direction. Okay. These all are the given problems, given values. Okay. These are the four forces acting outwards of the points. Okay. Outwards of the acting outwards of the four forces through one origin. Uh, Here one force. This is first force. Its magnitude value is 104 Newton. Its angle is 10 degree from the x-axis. This is the second force. Its magnitude value is 156 Newton. This force is inclined from the y-axis 24 degree. This is third force. This third force magnitude value is 252 Newton. It's a 3 degree inclination from the x-axis. This is the fourth force. Its magnitude value is 228 Newton. And this force is inclined to y-axis 9 degree. Okay. First of all, we solve the problem. In this problem, okay, in this given problem, this is a force one. This is first force. Its magnitude value is 104. So first we noted F1. This is F1. Its magnitude value 104 Newton. So F1 equal to 104 Newton. This force is second force. So it's denoted as F2. F2 equal to 156 Newton. This is third force. It's denoted as F3. Its value, its magnitude value is 252 Newton. So F3 equal to 252 Newton. This is fourth force. Its magnitude value is 228 Newton. So it's denoted as F4 equal to 228 Newton. Next, we have to find its angles. Okay, this is F1 force. It makes an angle 10 degree from the x-axis. So it is denoted as theta 1. So theta 1 equal to 10 degree. Next, second force 156 Newton. It is 24 degree from the y-axis. In this problem, uh, we have to find the angle from the x-axis. Okay, we have to take the angle from the x-axis only. We are considering to solve the problem. Okay, in this case, this is x-axis, this is y-axis. So in between angle is 90 degree. So we have to find the angle. Second force is inclined to the x-axis is. So we have to find this angle. Okay, so this angle. So x-axis, y-axis, in between angle is 90 degree. So already the 156 Newton force is inclined 24 degree from the y-axis. So we have to find and the x-axis, y-axis angle 90 degree. So here we are mentioned 90 degree. Next, it's 24 degree from the y-axis. So 90 degree minus 24. So finally we got 66 degree. So theta 2 equal to 66 degree from the x-axis. The second force is 66 degree from the x-axis. We find. Next, we consider the third force, F3. So F3 magnitude value is 252. Its angle is denoted as theta 3. So the third force is inclined to the x-axis. X-axis means its angle they are given it's 3 degree. So we mention here theta 3 equal to 3 degree. Next, we have to find the fourth force angle theta 4. So here the fourth force is inclined to the y-axis 9 degree. So we have to we have to find the angle between angle from the x-axis. So in this angle we have to find. So the x-axis and the y-axis, this angle is 90 degree. The 228 Newton is 9 degree from the y-axis. So we have to find the theta 4 from the x-axis. So first of all, we substitute 90 degree. So 90 degree means this is x-axis, this is y-axis. In between angle 90 degree. Next minus 9 degree. 228 Newton force is from the y-axis 9 degree. So 90 minus 9, so 81 degree. From the x-axis onwards, this fourth force angle theta 4 equal to 81 degree. Okay. Next, we have to find sum of horizontal components. In this problem, all the forces are in equal inclined forces. Okay, So if we consider any one inclined force means we have to separate horizontal force and the vertical force. In this case, 104 Newton is 10-degree inclination force. Okay, 104. Okay, 104 magnitude of force. It's acted 10-degree inclined to the reference side, 10-degree inclination to the x-axis. So this inclined force is further separated in horizontal axis, horizontal force and vertical force. In this case, okay, in this case, this is a inclined force. So these inclined forces further divided into two forces. One horizontal force, another one is vertical force. This Okay. This inclined force is further separated in horizontal force and vertical force. This inclined force direction is like this. So its horizontal force direction is like this. Next, we have to draw in vertical force. That vertical force is in upward direction. Okay, this inclined force, okay, this is inclined force. This inclined force is further separated in horizontal force and vertical force. Okay, its horizontal force direction is rightward direction. So rightward direction means we consider the positive signs. Here the vertical force directions also in upward direction. So upward direction means we consider positive directions. So we separated. This is a 104 magnitude of force. Its angle is 10 degree. So here horizontal component is 104 cos 10 degree. Its vertical component is 104 sin 10 degree. So here we are some of the horizontal force we have to calculate. So here its horizontal component is 104 cos 10 degree. Its direction is rightward direction. So it considered as a positive side, 104 cos 10 degree. Next we are considering the second force. It's the second force direction is like this manner. In this case, the horizontal component is like this manner. Here vertical component is like this manner. Okay, okay. Here the horizontal component is in leftward direction. So leftward direction means it considered as a negative sign. So here the horizontal component is 156 cos. Here theta 2 value 66 degree. So horizontal component is 150 minus 156 cos 66 degree. Here the vertical component is upward direction. So it considers a positive sign. Okay. Here vertical component is 156 sin 66 degree. Okay. Because vertical direction means it considers as a positive. Here the horizontal component is in a leftward direction. So it considers a negative value. So we are considering, we noted here minus 156 cos 66 degree. The same procedure we are following here. And this is a third force. This third force direction is in like this manner. So this inclined force is further separated in horizontal force. Its horizontal component is in like this manner. Its vertical component is in downward shape. Here its horizontal component is okay 252 cos 3 degree. Its direction is leftward, so it considered as a negative sign. So minus 252 minus 252 cos 3 degree. Next downward direction means its vertical component is minus 252 sin 3 degree. Okay. Now we are consider only horizontal component. So minus 252 cos 3 degree. Here we mention, okay, minus 252 cos 3 degree. We mention the same procedure we follow in fourth force. The fourth force direction is in like this manner. So this inclined force is further classified in horizontal component and vertical component. Its horizontal component is like this manner. Its vertical component is downward direction. So its horizontal component value is 228 cos. Its angle is from the x-axis theta for 81 degree. So its direction is leftward direction. So it is considered as a negative sign. So minus 228 cos 81 degree. Its vertical component is a downward direction. So negative sign minus 228 sine 81 degree. So here horizontal component is minus 228 cos 81 degree. Here we are mentioned minus 228 cos 81 degree. Finally, we calculate all these values. Finally, we calculate all this value by using calculator. Cos 10 into 104, its value is 102.4. Cos 66 into 156, its value 63.44. Next cos 3 degree into 252, its value is 251.64. Next cos 81 into 228, its value 35.66. We are considering the sign conversion we have to follow. Finally, we simplify this step. Finally, we simplify this step. The sum of horizontal component. The sum of horizontal component equal to minus 248.32 Newton. Okay, now we found the sum of horizontal component of the given four forces. Next, we have to find the sum of vertical component of the forces. Here, the sum of vertical component is denoted as summation V. Here sum of horizontal component denoted as summation of H. Okay. Here, sum of vertical component of force we have to find. Sum of vertical component equal to here consider the first force. Its the vertical component direction is upward, so it is considered as 104 10 degree. Its direction is upward. So here we have mentioned 104 sin 10 degree. Upward direction means positive sign. Next, we consider the second force. It's the vertical force also in upward direction. So we are mentioned we are mentioned the vertical force is 156 sine sine theta to value 66 degree. Okay. So here applying we substitute 156 sine 66 degree. Okay. Next we are considering the third force. In this case, the vertical force is okay. This force. In this case, the vertical force is in downward direction. So downward direction means it's a negative sign. So its a vertical component is minus 252 sine 3 degree. Now we substitute here minus 252 sine 3 degree. Next we consider the fourth force. The fourth inclined force shape is like this. So its vertical force is in downward direction. So its vertical component value is minus 228 sine 81 degree. Here theta 4 value 81 degree. Okay. So downward direction means it is considered as a negative sign. So minus 228 sine 81 degree. Finally, we find the all the value for these steps. Okay, by using calculator. Sine 10 into 104, its value 18.06. Next, we find the sine 66 into 156, its value 142.5. Next, here the minus sign we are considered. Here minus sign we keep here. Next, sine 3 degree into 252, its value 13.18. Sine 81 into 28, its value 225.2. Finally, we simplify these steps. We found sum of vertical component equal to minus 77.282. Okay. Now we find the sum of horizontal component and the sum of vertical components. Next, we have to find the magnitude of resultant force. Here, the magnitude of resultant force formula R equal to sum of square root of sum of horizontal component whole square plus sum of vertical component whole square. Here, we substitute the sum of horizontal component value and the sum of vertical component value. Okay, in this step, we substitute the sum of horizontal component value and the vertical component value. So R equal to square root of sum of horizontal component value minus 248.32 whole square plus sum of vertical component value minus 77.82 whole square. Finally, we simplify this step. We got resultant force. Magnitude of resultant force equal to 260.2 Newton. Okay. Next, we have to find its direction. The direction of resultant force formula equal to tan alpha equal to sum of vertical component divided by sum of horizontal component. So we have to find the alpha value. So alpha equal to tan inverse of sum of vertical component divided by sum of horizontal component. In this formula, we substitute sum of vertical component and sum of horizontal component values. So tan inverse of sum of vertical component value is minus 77.82 divided by sum of horizontal component value is 248.32. So finally, we got alpha value 17.4 degree. Okay. In this problem, we found the magnitude of resultant force 260.2 Newton and the direction of resultant force alpha is equal to 17.4 degree. So finally, we draw one, we show its directions because the sum of horizontal component value is negative. So minus 248.32, then only we are considering the leftward direction. It's the sum of horizontal component value. So sum of vertical component value also in negative direction. So negative sign means its direction in downward. So sum of vertical component is equal to minus 77.82. Here the resultant force magnitude value 220, 260.2 Newton. Its angle, the alpha value is 17.4. Okay. This is the final output of the given, final result of the given problem. Okay. Thank you. Thank you for, thank you so much. We will discuss the next problem in next class. Thank you.